Hello everyone, welcome back to 3 Deviations. In today's video, we are kind of going to be bridging between Unit 3 and 4. Before we get started with our new type of calculus, we are going to introduce just one new topic that is going to be so helpful in the rest of the course. We are going to be using this. So differentiation and anti-differentiation are really, really important to calculus. And this is something that might not be relevant for the first few parts of Unit 4, but definitely this is something that you should take notes on, keep in the back of your head, because we will be applying it before we talk about this more. It just might be a little while, because we're going to be introducing a lot of new stuff at the beginning of Unit 4, and we're going to jump back to this anti-differentiation stuff to prove a very important theorem. So the question that we ask here is, how does one reverse the derivative, right? So say I'm a physicist and I have an acceleration function of a particle, and I want to find its velocity function. Well, we know that the acceleration is the velocity of the derivative of the velocity, so we just need to go in reverse and find what the antiderivative of that is. So we can define the antiderivative pretty rigorously. We just say a function f is the antiderivative of the function little f if big F prime of x is equal to little f of x. And we also add a constant c to an antiderivative, because if you remember, when we take our derivatives, the constant terms go out to 0. So if I do an antiderivative, say I get a cubic function, well, this antiderivative could, because we get rid of that degree of certainty with that constant term, since that goes out in the derivative, we've lost our y-intercept. So we need to have a constant to indicate that it's really a family of curves that could really have any y-intercept along that axis. So that's why we add that constant c. That's important. All right, so we're not going to do any examples, because this is really a lesson that I think you should probably just want to write down in your notes to save for later. We'll be doing we'll have a unit dedicated to how we anti-differentiate things. So we're not going to be doing any examples really today, but I do want to show you the basics of what I'm talking about here. So I'm just showing you a basic antiderivative table. So if I have a function c times little f of x, that will go to c times f of x. And if I have a function, sum of functions, little f of x plus little g of x, that goes to big F of x plus big g of x. That's the antiderivative. If I have a function x to the n, this is kind of the power rule for anti-differentiation. It goes to x to the n plus 1 over n plus 1, given that n does not equal 1. And I recommend proving some of these algebraically. Like, it's not very hard given the power rule to reverse it. If I have the function 1 over x, that becomes the natural log of the absolute value of x. If I have e to the x is our special function, so that stays e to the x when we reverse the derivative. If I have a function b to the x, that goes to b to the x over the natural log of b. If I have cosine of x, that goes to sine of x. If I have sine of x, that goes to negative cosine of x. If I have secant squared of x, that goes to tangent of x. If I have secant x times tangent x, then that becomes secant of x. If I have 1 over the square root of 1 minus x squared, that becomes the inverse sine of x. And if I have 1 over 1 plus x squared, that becomes the inverse tangent of x. If I have hyperbolic cosine, that goes to hyperbolic sine. And if I have hyperbolic sine, that goes to hyperbolic cosine. So really what I think is really important to remember is this guy here, this guy here, this guy there, all of this trig stuff, and these two guys. Exponentials, fairly important, but we'll talk about that later. Hyperbolic, we'll talk about that later as well. But those are the main functions that I want you to know, remember the antiderivatives of, because we'll be tinkering around with that later on in Unit 4, and we won't be reviewing it beforehand. Thank you for watching, and we'll see you guys in the next video to introduce integral calculus.